So we've all seen AI do some pretty wild stuff, right? It can master chess, write poems, even create incredible art. But what's really next? The true frontier isn't just about AI thinking anymore, it's about AI doing. We're talking about teaching AI to actually understand and interact with our physical world, and let me tell you, that is a whole different ballgame. This is what researchers are calling physical AI. And look, this isn't some far off sci fi dream anymore. It's the robot arm in a lab that's learning to pour a drink, or it's the autonomous car trying to navigate a crazy intersection. AI is literally leaving our screens and becoming a part of our physical reality. But here's the catch. For any of this to work, like really work, safely and reliably, the AI has to get one thing, one absolutely crucial thing right: physics. It has to know deep down that a glass shatters if you drop it, or that a closed door has to be opened before you can go through it. It has to get the basic rules of the universe. So, okay, that raises a huge question, doesn't it? How do we even teach an AI these rules? And maybe even more important, how do we test it? How can we be sure it really gets it, or if it's just making a lucky guess? This right here is the AI judging problem. And here's where it gets really tricky. Right now, a lot of AI judges, these are the models that are supposed to grade other AIs, well, they can get pretty confused. They might look at a scene and see all the right pieces, a robot arm, a block, a wall, but they might miss the basic rule that, you can't just shove a solid block through a solid wall. They get fooled by stuff that looks plausible, even when it's physically impossible. So that's the big puzzle, right? How can we build an AI judge that isn't so easily tricked? How do we teach it to tell the difference between what's real and what just looks real? Well, a new research paper from some brilliant folks at NVIDIA and the University of Maryland might just have the answer, and it's called PhyCritic. So what is PhyCritic? Well, you can think of it as a whole new breed of AI. It's a specialized critic model built from the ground up for this one specific challenge: to be an expert judge on whether an AI's plan actually makes sense in the real world. Okay, just so we're all on the same page here, what exactly is a critic model? Basically, it's an AI teacher. When one AI comes up with an answer, the critic's job is to look at it and go, yep, that's right, or nope, that's way off, and here's why. It's that feedback loop that's so important for learning. Okay, so what's the secret sauce here? What makes PhyCritic so different? It all boils down to this really simple but super powerful idea. The core idea is just brilliant. Think about how a human expert does this. If you ask a top chef to judge two recipes, they don't just glance at the ingredients. No way. In their head, they're already cooking the dish, figuring out the perfect way to do it themselves. Then they look at the other options. And that is exactly how PhyCritic is trained to think. So how do they do it? It's this really clever two-stage training process. First, there's a warm-up where the AI basically goes to physics school. It learns all the core concepts. Then, and this is the magic part, it learns how to judge other AIs. And this is the key, it only gives its opinion after it has already solved the problem itself. It creates its own perfect answer to use as a gold standard. Okay, let's make this real. Here's a great example from the paper. The task: cook some vegetables. A robot has already put the tray in the oven, and the door is shut. The AI then has to figure out what's the most logical thing to do next. All right, so it gets two different suggestions from two different AIs. The first one says, press the start button. Okay, seems pretty reasonable. But then the second AI chimes in and says, push the baking tray into the oven. Now, you and I know that's wrong, but an older AI critic might actually get tripped up here. Pushing a tray into an oven is a valid cooking step, right? It's just not the right one now. And this is where PhyCritic just blows the others out of the water. Before it even looks at those two answers, it thinks for itself. It looks at the scene and reasons, okay, tray's in, door's closed, the only logical next step is to turn the oven on. So now, when it's time to play judge, the job is super easy. It just compares those two suggestions to its own perfect answer. It instantly knows pushing the tray is wrong because, hello, the door is closed. So it can say with total confidence that response 1 is better. This solve before you judge method is what makes it so stable and so accurate. All right, so this all sounds amazing in theory, but the proof is in the pudding. The researchers really put PhyCritic to the test. So how did it actually stack up against other top models? Well, on a brand new test designed specifically for physical reasoning, PhyCritic, it kind of crushed it. It scored a 68, which is way ahead of other big open source models like Eagle and Quen. And get this, what's really mind-blowing is that it scored a whopping 16.4 points higher than the original model it was built on. That massive jump just proves how incredibly effective this whole two-stage, think-for-yourself-first training method really is. Okay, so let's zoom out. Better AI scores are cool for researchers, but what does this actually mean for us in the real world? Why should you care about this breakthrough? Well, it means we're getting closer to having robots in our homes that can actually help out without, causing a disaster. It means safer and smarter self-driving cars that can truly understand the world around them. It also just sets a much higher standard for how we test AI. And on top of all that, it's a much more efficient way to train AI, which in this field is a huge, huge win.
You know, this really blows the doors open. By teaching an AI to understand a problem for itself before judging others, we're building systems that are more grounded, more reliable, and just smarter. And it leaves us with a really exciting question to chew on. If AI can finally, reliably judge the physical world, what are we going to build with it next?